Now this is a real life example of a queue. Now suppose this is a ticket counter and these are three people waiting in a queue. This is a queue of three people waiting for the ticket, and suppose a new person wants to come into this queue, then he can only join this queue from the rear end and not from the front end. So the new person can only be added into this queue from the rear end. Now this guy came first into this queue, so he will take the ticket and move out of this queue. Then comes the turn of this guy, he will take the ticket and then move out of this queue. So this is why a queue is called first in first out type of data structure. Now out means deletion. So in a queue, the element which is added first is always the first one to get deleted from the queue. Now in this queue, first this 5 was added into this queue, then this 10 was added into this queue, and then this 15 was added into this queue. Now if I am to delete an element from this queue, then this 5 should get deleted. First in, first out. And again if I perform another deletion operation on this queue, then this 10 should get deleted. And if I want to insert an element into this queue, then an element should always be inserted from the rear end of the queue. So keep this in mind that an element is always deleted from the front end of the queue, and an element into the queue is always inserted from the rear end of the queue. Now this is a linked list and it consists of 4 elements. Now to create a queue or to implement a queue using a linked list, we need to make a linked list behave like a queue. And how can we make a linked list behave like a queue? We can do that by following some property of a queue, and the property of a queue is that an element can only be inserted from the rear end of the queue, and an element can only be deleted from the front end of the queue. Now imagine this linked list as a queue which consists of 4 elements, 5, 10, 15 and 25 in this case. Now if I want to insert a new element in this queue, then I need to add a new node from the rear end of this queue. And if I want to delete an element from this queue, then the node should be deleted from the front end of the queue. So this node should get deleted in case I perform a deletion operation on this queue. In this video, I am going to run you through this program, and this should just be a walk in the park for you if you understood my previous video on stacks. And also, I am not going to explain you everything in detail in this video, like what is this struct node, how to create this main function, or what is this malloc, because I've already covered those in my previous videos. So let's get started. Now this program is almost the same as the last one, except there are very few differences, like instead of top equal to null, we have front and rear equal to null, because in a stack we only have one end called the top end, but in a queue we have front end from where the elements are deleted and rear end from where the new elements are added into the queue. And if the queue is empty, then the value of front and rear are equal to null. And initially we don't have any data inside the queue, so the queue has to be empty. So initially we set front and rear equal to null. Now this is a user-defined function named insert to insert elements into the queue. This is user-defined function named del to delete elements from the queue, and this is user-defined function named display to display elements from the queue. Now the main function here is essentially the same as the one from the last video. These printf statements display the choices to the user, and this choice and this num are both declared here of type int, and if I enter 1 as a choice, then this case 1 gets executed and it tells me to enter an element to insert into the queue, and this scanf statement lets me enter the number. So if I enter 7 and hit enter, then that's it. A new element 7 has been inserted into the queue. You know how function call works. So when this insert function gets called, then it gets called with the number that I just entered, which is 7 in this example. So when this insert function is called, then 7 is passed into this function. So the value of num here should be 7 in this example. Now the main thing to understand here is that how does this insert function inserts an element into the queue. And mind you, element in this program is num of type int, but it can also be a data of other data types as well. Here I have declared a variable named temp of type struct node, and it's a pointer. This malloc function, I had explained this in detail in my previous video, and all this does is that it creates a new node and assigns the address of that node to this variable temp. And since this variable temp is a pointer, therefore it's obvious that it has to store some address. If the malloc function returns null, then it means memory is full. And if this function returns null, then null will be assigned to temp. And this is exactly what this if statement checks. If temp equal to null, then it means overflow. Overflow simply means that memory is full. And I don't think this if statement will usually be true in your case, because I don't think your computer will run out of memory while running this program. All this code here is the main focus of this insert function. It is responsible for inserting a new element or data into the queue. So now I am going to explain you all this. Temp will always store the address of the new node that would be created. And suppose this insert function gets called with the value of num equals to 7. Then 7 will be assigned to temp info, which is the info part of the new node. So 7 will get inserted into the queue. At this point, the queue is empty. There are no elements in the queue, and when the queue is empty, then the value of front is equal to null and the value of rear is also equal to null. Now the insert function gets called with the value of num equals to 7, and 7 is assigned to temp info, which is the info part of the new node, which is this. So 7 goes here and 7 gets inserted, the new element gets inserted into the queue. Temp link, or the link part of the new node, is assigned null, so null goes here. Now you need to understand that even if there are 100 nodes in the linked list, and if you want to add a new node into that list, then the new node will be added from the rear end of the queue or at the end of the linked list. So the new node that will be added will always become the last node in the list. And the link part of the last node is always equal to null. So assigning null to temp link or the link part of the new node is absolutely fine. The new node has been added into the linked list or the new element has been inserted into the queue. But did you notice one thing, that the value of front and the value of rear are still equal to null and they need to be updated. This insert function is called with the value of num equals to 7. This malloc function created a new node and assigned its address to temp. So temp info, the info part of the new node, is assigned num, which is 7, and the link part of the new node, which is temp link, is assigned null. Now if this if statement is checked, then it will evaluate to true, because indeed the value of front at this point is equal to null. So front will be assigned the value of temp. And what is temp storing? Temp is storing the address of the new node, which is this node. So now front is equal to this node. Front points to this node. The value of front has been updated, and suppose the address of this new node is 1002. So front stores the address of this node. It points to this node, because bear in mind that front and rear are both pointer variables. They will always store address. And this if statement will only be true if the node to be inserted into the list or the element to be inserted into the queue is the first element. Because just imagine the state of this linked list, which now contains one node. Just imagine its previous state. The value of front was equal to null, which was changed with the help of this if statement. And now if we again run this insert function, then the value then this if statement will evaluate to false. This if statement was true, therefore this else block will not get executed. And this statement rear equals to temp is outside this if else block, therefore it will get executed in any case. Now the value of rear is still equal to null and it also needs to be updated. And this statement rear equals to temp will change the value of rear to point to the new node. So now rear points to this node, which is the new node added into the list. Now if again this insert function gets called, and this time with the value of num equals to 25, then a new node will be created. With the help of this statement, the info part of the new node will be assigned 25 and the link part of the new node will be assigned null. And suppose the address of this node is 1006. Now this node, the previous node, needs to be updated to store the address of its next node, which is this node, the new one. Now this if statement will evaluate to false and this else block will get executed, and this is what it does. Now rear link means link part of this node, the previous node, and it is assigned the value of temp, and temp stores the address of the new node, which is 1006 in this example. So 1006 is assigned to rear link, which is the link part of this node, and this is how it should be. Now these two nodes are connected. This node stores the address of its next node. Now rear needs to be updated. It is not at the right position. Rear should be at the end of the list, and this is exactly what this statement does. It assigns rear the value of temp, and temp stores the address of the new node, which is 1006 in this example. So 1006 is assigned to rear, and rear now points to this node. So this was the insert function. You can go on and on with it. You can add more nodes if you want, and you can think of this list as two elements in the queue, and a new node or a new element can only be added from the rear end of the queue. Now let's move to the delete function. The delete function deletes a node from the beginning of the linked list, or it deletes an element from the front end of the queue. Now here I have declared a variable num of type int and a pointer variable temp of type struct node, which is very common in these linked list programs. Now in this function, first we need to check if the list is empty or the queue is empty, because if it is empty, then there is no point trying to delete something. So the queue empty or underflow condition in case of a linked list is checked using this if statement. If front is equal to null, then printf underflow. And with the help of this return statement, the program control moves out of this del function, and none of these statements will be executed if this if statement turns out to be true. If the queue is not empty, then this if condition will become false and these statements will get executed. Now temp will be assigned the value of front, and front is the first node in the list, or the front end of the queue. Now temp stores the address of the first node, so temp also points to the first node. Now temp info means info part of this node, the first node, which is 7. So 7 is assigned to num, which is an integer variable. Now front is assigned the value of front link. Now what is front link? Front link is the link part of the first node, and except the last node, the link part of every node contains the address of its next node, which is 1006 in this example. And if the first node in this list gets deleted, then the second node will become the first node. So in this example, 1006, which is front link, gets assigned to front. So now front points to this node, the second node, and this node is now delinked from this linked list. Now even though this node has been delinked from this linked list, it still occupies some space in the memory, because memory allocated using the malloc function does not free by itself, and we need to free it using the free function. And temp has the address of this node, which needs to be freed. So this was the whole point of assigning temp the value of front at the beginning. And at the end, this return num isn't anything special, because this function is of type int. Therefore we need to return some integer value, which is num in this case. Now the display function. In the display function, we first need to check if the queue is empty. Now this is the same if condition we used in the delete function. If front is equal to null, then print underflow, and With the help of this return statement, the program control should move out of this display function and none of these statements should be executed. If this if condition is false, if the queue is not empty, then with the help of these statements, the elements inside the queue will get printed on the screen. This is essentially the same display function that I explained in the previous video and in my linked list tutorial. So I am not going to go into detail. So a quick run through. P is assigned the value of front, and front is the first node. It is the entry point. And while P is not equal to null, keep printing the info part of each node. Now the info part of the first node is 7. The info part of this node is 25, and in this case it is 65. And each time also increment the value of P. Move P to the next node. P link means the link part of a node, and the link part of a node contains the address of its next node, except the last node which contains null. So when P is at the last node, when P is here, then P link will be null. So null will be assigned to P. So at the end, when this while loop runs, this condition will become false because P will be equal to null. So the program control will move out of this while loop. Now I am going to run this program, and first let me insert some elements into the queue, 5 and 25. Now 3 for display, and it shows 5 and 25 queue elements. Now if I add another element into this queue, then the new element should be added from the rear end of the queue, and it should show next to 25. So let's see. 1 for insert, insert 15, display, and so this 15 is added from the rear end of the queue. Now if I delete an element from this queue, then this 5 should get deleted. An element should be deleted from the front end of the queue. So let's see. 2 for delete, now display, and 5 has been deleted, only 25 and 15 are in the queue. Now I'm going to delete both these elements. 2 for delete and again delete. Now both these 25 and 15 have been deleted from the queue. Now the queue is empty. Now if again I use the delete function, then it should show underflow. See, it shows underflow. So this is the end of this tutorial on how to implement a queue using a linked list.